today's competitive market, ensuring product quality and safety is no longer just a good practice, it's a necessity. So imagine getting into your car, believing it to be a safe and reliable mode of transportation, only to discover that a fundamental safety feature, like an airbag, could pose a serious threat to your life. That is precisely the situation that millions of Toyota owners face when the recall was announced in 2023. Over 1.1 million vehicles globally, including popular models like the Camry, Corolla, RAV4, and Highlander, spanning model years 2020 to 2022, were recalled due to airbag defects. The United States accounts for the largest portion of affected vehicles, with owners being notified and required to bring in their vehicles for free inspection and repair. The massive recall results in substantial financial loss for the company and erode consumer trust. So, according to a study by the American Society of Quality, or also called the ASQ, the cost of product defect can account for 15% to 20% of manufacturing companies' total revenue. So the defects not only include significant repair costs, but also negatively impact the company's reputation and customer satisfaction. These incidents raise several important questions. How could such a defect go unnoticed? What measures were in place to ensure the quality and safety of the airbags? How can we prevent similar incidents from happening in the future and reduce production costs due to product defects? So the answer to the question lies in a systematic approach to identifying and addressing potential value, known as Value Mode and Effects Analysis, or FMEA. So let's jump into the first part, general introduction, to get to know about FMEA better. So an FMEA is an organized set of procedures designed to detect and analyze potential product or process failures and their implications. So it also entails establishing strategy to prevent or reduce the possibility of these failures and document the entire process. This method complements the challenge of identifying the requirement that the design or process must achieve to meet the expectation of the customer. So FMEAs are categorized into three kinds based on their use. The first one is Concept FMEA, or also called CFMEA. The second is Design FMEA, or also called as DFMEA. And the last one is the Process FMEA, or also called the PFMEA. So the Concept FMEA is used to evaluate concept before the hardware is developed. And the Design FMEA is used to detect and prevent failure modes associated with product design in order to validate the established design parameter for a specific functional performance level at the system, subsystem, or component level. So the last FMEAs, also called the Process FMEA, will examine possible ways a product could fail due to issue in manufacturing or assembly process, pieces, and inappropriate assembly method. So here is the origin and history of development of the FMEAs. The US military force formally implemented FMEA in the late 1940s. In the 1960s, it was utilized as a design process by the aircraft industry, which had apparently reliability and safety needs. In the late 1970s, Ford Motor Company introduced FMEA to the automobile industry for safety and regulatory purposes. They also utilized it to enhance manufacturing and design. So for the purpose, FMEA is used to guarantee that the new design, the technique, or system fit the requirement under a particular situation, such as purpose and constraint. The FMEA technique offers various advantages, including lower cost, shorter project to market times, and greater product quality and dependability, and increased safety. The ultimate goal is to improve customer satisfaction, which leads to greater competitiveness and a favorable market image. So where do people usually apply FMEA? So the FMEA is widely utilized in the industrial industry, including semiconductor processing, food service, plastic, power plants, software, and healthcare, at various stages of the product life cycle. So to understand clearly FMEA, we should deep dive into some theoretical basics of this tool, including function, failure mode, cost control, effect analysis, risk priority number, and recommend action. So what this basic item means to FMEA. Why should we know it? The first one is function. It means what factors of item are responsible by what department or staff who have competencies about that. And the second thing is failure mode. This refers to how process or system can fail to perform its intended function. The failure will be potential have possibility to happen. So the next one is the cause. It is about the reason for the failure, that by asking why until the root cause is determined. The next one is control. It is the method or action that currently in place to reduce the risk. And the next one will be the effect analysis. It means that the potential effect analyzed after defining the failure mode and how each failure mode would impact the system, process, or its end users. So next one we will have about the risk priority number, or also called as the RPN. It is a ranking of the failure modes that based on the risk will be comprised by three factors, such as the severity of the effect, occurrence of the cause, and the detection of the cause by the formula S multiply with O and multiply with V, while in that S or severity is the seriousness of the failure mode's effect on the system or process, evaluated based on 1 to 10. And the occurrence or called O is a ranking number from 1 to 10 associated with the likelihood that the failure mode and its associated cause will be present. And the last one is detection. D or is a ranking number from 1 to 10 associated with ability to detect the failure mode before it reaches the customer and its end user. So the last one will be preventive actions. FMEA helps in designing preventive action to solve the high-risk failure modes in time, such as design changes, process improvement, or additional control to reduce the likelihood or impacts of failures on system or users.
Okay, so now we will deep dive into how FMEA works with detailed steps. From that, we can understand more and know how to use it simply at first. Okay, so before following steps of FMEA criteria, we should create an organizing team who have competencies and are responsible for defining the scope, analyzing and recommending action relevant to the failure mode. Next, we will look into 4 steps. Step 1, we're gonna detect the failure mode. We will use engineering and business judgment to identify its function, failure, effect, causes, and current control. The second step is to assign the severity number S to rate the severity of the effects. Third step is to assign the probability of occurrence, O, to rate the likelihood of occurrence of the cause. Fourth step is to assign the detection number, D, to rate the likelihood of detection of the cause. Fifth step is to assign the risk priority number, RPN, by multiplying the 3 ranking S, O, D together to get the risk priority number for each failure mode. And the last step is to take action by developing effect action to solve most serious concern based on the RPN score. So we're gonna moving on to the benefit and limitation of using the FM.
So first, we will talk about the benefits and the limitations of FMEA. So about the benefits, first one is the proactive risk management. This tool will help you to witness the potential failure modes in system before it happens, so you can be proactive to manage risk and think of corrective solution as soon as possible. The second benefit is it will inform decision making by having a structured way to prioritize the risk ranking based on the S, O, D, and can help you to allocate resources effectively to solve and helps to estimate alternatively. So next we will talk about the limitation of the FMEA. The first limit of FMEA is it was so time consuming because conduct this tool takes much time and requires significant effort with team members, especially for complex systems. The second is subjectivity. First, like severity, occurrence, and detectability can be subjective and may vary, leading to inconsistent within team members. And lack of experience can affect the identification and evaluation.
Okay, following by the limitation and benefit that I have mentioned, we're gonna have some comparison of FMEA with SBC, or called statistical process control, and root cause analysis, RCA. So the first difference between FMEA and SBC is the purpose. While FMEA is systematic and predictive, SBC is reactive and monitoring to maintain stable process. The application whereas the FMEA is applied in design and development phases. Process improvement initiative. The SPC is using manufacturing and production processes quality control. Next up is the benefit why people use FMEA more than SPC, because FMEA evaluate the potential failure modes, their effect, and their root cause to have comprehensive solution for optimal handle more than the SPC. But it has some limitation that SPC have, is SPC use real-time data, so this allows to have the immediate action to maintain process stability and quality. Okay, so next up we have a comparison between FMEA and RTA, or root cause analysis. The first difference is the purpose. While the FMEA is mitigate potential problems early in the planning stages, the RTA address the root cause of the problem to have solution to prevent the recurrence. And next up is the timing. Whereas the FMEA is typically performed during the design or a planning phase, RCA is conducted after the failure has occurred. But the benefit of the FMEA is that it is designed to identify potential failure modes and their impacts before they occur, while the RCA is in reverse. And the limitation that the RCA have but the FMEA don't have is RCA provide a thorough understanding of the factor to apply the comprehensive solution for these problems in the production process. Okay, so enough of the theory. Let's moving on to the illustrative example that we want to present to you. So you may know the Ford Motor Company. Basically, it is the one of the largest and most well-known automobile manufacturer global, founded by Henry Ford in 1903. Based in Dearborn, Michigan, the company produced a wide range of vehicles from cars to trucks and SUV, and it is recognized for its iconic models like the Ford Mustang, F-150, or even the Ford Explorer that you can see it usually. So basically, Ford has applied the FMEA not only to identify potential issues in their design and manufacturing processes, but also to address them early before they ever reach the customer. So we will explore how Ford integrates the process FMEA with the specific focus on the brake system as an example. Okay, so moving on to from the process FMEA to ensuring the perfection in manufacturing, we will move to process FMEA, which Ford applied to ensure that the assembly process itself doesn't introduce defects that could compromise vehicle safety or quality. So here how the PFMEA played a crucial role in Ford. The first one is defining the scope. The scope of PFMEA focus on the key stages of the brake assembly process, like the caliper installation and brake pad alignment. This critical point where mistake could result in defective brake reaching the customer. Next one is identifying process failure modes. Ford anticipates potential issues such as misaligned brake calipers or incorrect torque application during the assembly. This kind of defect might lead to brake failure or uneven wear, which could have the serious consequence for vehicle performance. Third one is effect and severity rating. So if the calipers are misaligned, brake could fail to function correctly, leading to accident. This failure mode is given a high severity rating, signaling that it could pose a significant risk if not addressed during the assembly process. Fourth one is root cause in the process. First, identify the potential causes like the operator error or faulty assembly tools. For example, an outdated torque wrench might lead to an improper tightening or bolt, causing the caliper to come loose over time. The fifth one is assessing occurrence and detection. By analyzing the batch assembly data, Ford estimates how often these process issues occur. They also look at the effectiveness of existing control, such as manual expectation, to determine how likely they are to catch this error. If detection is weak, Ford considers it a priority to improve this control. Okay. So moving to the RPN calculation, just like the design FMEA, Ford calculate the RPN for each potential process failure. If the RPN for misaligned caliber is high, Ford knows it's a critical area to address in the assembly process. The seventh is taking corrective action. Based on the RPN, Ford implements the corrective action. For instance, they may introduce the automatic torque system to ensure the precise tightening, or install the laser guide tools to improve the brake pad alignment. This action reduces the chance of assembly errors reaching the customer. The last one is re-evaluation and improvement. After these changes, Ford reassess the assembly process. Automated tools and better equipment drastically reduce the occurrence of misaligned calibers or improper torque application. This lowers the RPN and assure that the risks in the manufacturing process are now under control. From all of those actions, we can see that Ford implementation of automatic torque system and laser guided tool address the identified risks. This improvement reduce the occurrence of assembly defects such as misaligned caliber, which in turn enhance the overall reliability of the vehicle assembly process. Fourth, dual application of DFMEA, Design FMEA, and PFMEA, Process FMEA, has proven to be an essential tool in preventing vehicle campaigns. By identifying the potential failure mode early in the design and manufacturing process, Ford can proactively prevent issues before they escalate into costly recalls or worse safety risks to customers. Through this structured approach, Ford has enhanced the vehicle reliability, reduced defects, and ensured customer safety, all while cutting down on production costs and time spent dealing with late-stage changes. The success of FMEA at Ford is clear. It is not just a process, but a fundamental part of their commitment to quality, innovation, and customer satisfaction. Okay, so after we have introduced you about the example that we list above, let's focus on what it could easily use in daily business. So the first one I want to mention is applicable industry. So FMEA is a versatile tool that is widely applicable across several industries. In the automotive industry, it plays a key role in improving the vehicle reliability, safety, and performance. A real example of FMEA is its use in developing the Toyota Prius hybrid system. Toyota engineers identify potential issues like the battery overreaching and motor failure, then made design changes such as improved cooling and backup safety features. This helped reduce the powertrain failures, boosting the brewer's reputation for reliability and efficiency. Similarly, in the aerospace industry, FMEA is essential for ensuring the safety and reliability of aircraft systems by eliminating potential risks. FMEA is used in aerospace, particularly in designing jet engines like turbofans. It helps engineers identify potential issues such as turbine plate wear or compressor problem that could lead to engine failure in flight. By recognizing these risks early, engineers can select the better material, improving manufacturing, and create backup system to ensure the safe and reliable engine operation. In the healthcare and medical device sector, FMEA is used to reduce risks to patients and enhance the quality of care. The manufacturing industry also benefits from FMEA, and it helps to improve the product design, enhance the process reliability, and reduce the operational risk. In the food and beverage industry, FMEA ensures food safety, quality, and compliance with regulatory standards. Lastly, in the defense and military sector, FMEA is critical for maintaining reliability and safety of defense systems and vehicles. An example of FMEA in the defense industry is missile guidance system. If a sensor or software fails, the missile could miss its target, causing the mission failure or unintended damage. FMEA help defense the contractor evaluate and prioritize these potential failures, allowing them to improve the sensor quality, add backup system, and refine software for reliable performance in combat. Okay, next up we will demonstrate about the condition for application. For FMEA to work effectively in a business, several important conditions need to be met. First, there must be a clear understanding of the system or the process, so the potential failure point can be identified accurately. It's also important to have the cross-functional team involvement, meaning that the different departments like engineering, quality, and manufacturing need to work together to share different perspectives. Data availability is a key too. At bad failure, customer feedback, and maintenance record will help guide the analysis. Commitment from leadership is essential, with senior management providing the necessary resources and prioritizing the process. FMEA should also have regular update and review to reflect any changes in system or processes over time. A risk scoring system, considering factors like severity, occurrence, and detection, should be in place to rank risk and decide where to focus effort.
Okay, so we'll be moving on to implementation strategy. So basically, implementing FMEA failure mode and effect analysis require a clear and structured plan that balances resources, time, and cost. First, build a dedicated FMEA team by gathering people from different departments like engineering, quality control, and manufacturing, and appoint a leader to understand FMEA and risk management. Next, set the focus of the FMEA, whether it's on the product design, the FMEA process, BFMEA, or the entire system to ensure the efficient use of the resources. Then, map the process or system by creating a detailed diagram to help identify where failures could happen. After that, identify possible failures by brainstorming with the team and using part data and customer feedback. Once potential failures are identified, rate the risk by scoring them based on severity, impact, occurrence, likelihood, and detection, ease of identifying the issue. Calculate the risk priority number (RPN) to prioritize the most critical failures. Assign resources for fixing issue, ensuring that time, budget, and staff are used wisely, and that the cost of fixing the issue makes sense compared to the benefit. Regularly track and review the progress by checking how well action plans are working and updating the FMEA system evolve. Make sure to keep records and report on identified failures, risks, and solutions to aid in future improvement and audits. Finally, train and raise awareness among employees so they understand how FMEA works and its important, embedding FMEA into company culture and handle future risks proactively.
Okay, so that is all the theory and example that we have provided you. So let's have a recommendation as well as the conclusion of the FMEA. So the application of failure modes and effect analysis FMEA within the context of developing a healthcare application. Our aim is to systematically identify, analyze, and mitigate the potential risks at stages of the app development process, which include the requirement gathering, design, development, testing, and deployment. We begin by identifying the key failure modes such as incorrect data processing, UI bugs, and the security vulnerability. The impact of this failure is significant. For example, inaccurate health data can severely erode user trust. To quantify the risk, we assign rating
on a scale from 1 to 10 for the severity as occurrence O and the detection D, and then calculate the risk priority number RPN using the formula RPN equal to S multiplied by O and multiplied by D. This metric helps us prioritize which issue to address first. To mitigate this risk, we recommend implementing robust encryption protocols, enhancing our testing framework, and conducting regular reviews and updates of our system. By adopting these strategies, we focus on the prevention rather than the correction, aligning with FMEA proactive approach to quality control. In conclusion, FMEA is an invaluable tool in quality management. It not only enhances the reliability, safety, and customer satisfaction of the app, but also significantly reduce the cost by minimizing defects and avoiding potential recalls. Ultimately, FMEA's systematic approach to identifying and addressing potential failure is indispensable, particularly in industry where high standards of safety and reliability are crucial.